Carbohydrates are the biomolecules that we'll be studying now. Carbohydrates are defined as polyhydroxy aldehydes or ketones. So these are the compounds which are made up with polyhydroxy means hydroxyl ions, hydrogen and oxygen atoms containing aldehyde group, that is CHO group, and ketonic group, that is CO group. So the general formula for carbohydrate is CH2O bracket outside N. N is any whole number. For example, in case of glucose, N is 6. So if we put this 6 value in place of this N, then it will become C6H12O6. That is the formula for glucose. So this is the molecular formula for glucose. Glucose consists of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. So carbohydrates can be simply classified as monosaccharides, disaccharides, and polysaccharides. Monosaccharides, saccharides means sugar. Monosaccharide means single unit of sugar. Disaccharide means two units of sugar linked to each other by a linkage called as glycosidic bond. Polysaccharides are the polymers which are made up with more than two number of monosaccharides. So in between these disaccharides and polysaccharides, there is one more group which is called as oligosaccharide. So oligosaccharide is the one that defines the polymer that consists of more than two monosaccharides and up to 9 to 10 monosaccharides. So a chain of monosaccharides more than 2, less than 10 or 11, it is called as oligosaccharide, and more than 11 it will be called as polysaccharide. In that case, there will be four classes: monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Now, monosaccharides are simple sugars which are made up with a single monomer, single unit of sugar, that is monosaccharide. For example, glyceraldehyde. So glyceraldehyde, it is a sugar consists of 3 carbon units. Now this nomenclature system can be understood by considering the number of carbon units which forms the skeleton of this monosaccharide. If the sugar contains a skeleton of carbon containing 3 carbon units, then it will be called as triose sugar. Example of triose sugar is glyceraldehyde. Another example is erythrose. This is a monosaccharide that consists of 4 carbon units. That means the skeleton of carbon consists of 4 carbon units. It is called as tetrose sugar. Ribose and deoxyribose sugar. These are also examples of monosaccharides that contains 5 carbon units in the carbon skeleton, and hence they are called as pentose sugar. So this is how the nomenclature system is depending on the number of carbon units: triose, tetrose and pentose. 3 carbon, 4 carbon and 5 carbon. Likewise, for a 6 carbon skeleton containing sugar, it will be called as hexose sugar. Examples are glucose, fructose, galactose, mannose. Now, the molecules of monosaccharides can exist as linear structures or planar structures, but when dissolved in water, many of them have a ring structure. That means whenever these monosaccharides are present in cell, in water, in cytoplasm, they are present in ring form. Ribose is a major component of nucleic acids which is present in ring form whenever it is present in RNA and DNA. In general, we divide monosaccharides into two categories depending on the functional group present or the chemical group present, as we have defined carbohydrates as polyhydroxyaldehydes or polyhydroxyketones. So on the basis of that, whether sugar contains aldose aldehyde group or ketone group, the sugars are classified as aldose sugar or ketose sugar. So monosaccharide containing aldehyde group will be called as aldoses. Monosaccharides having ketonic groups are called as ketoses or ketose sugar. Now let us see the classification of monosaccharides in further detail. 3 carbon containing sugar is called as triose sugar, that contains 3 carbons. So this triose sugar, it can be an aldose sugar or ketose sugar. Example of triose sugar from aldose category, that is the sugar that contains aldehyde group, is glyceraldehyde. You can see here that it consists of 1, 2, 3 carbons. CHO, this is the aldehyde group. So while drawing the structure of triose sugar, glyceraldehyde, we need to remember that glyceraldehyde belongs to aldose sugar, and therefore while drawing it, first draw the skeleton, that is C, C, C. Then this terminal carbon, make it CH2OH. Then the other end, as it is aldose sugar, make this group as CHO and rest of the carbons HOH. This is the structure of aldose sugar containing 3 carbons. Now let us draw the structure of a ketose sugar, that is triose. It contains 3 carbons. So draw 3 carbons, 1, 2 and 3. It is a ketose one. The example is dihydroxyacetone. So this group, that is C double bond O, is a ketone group, and this carbon will be CH2OH, CH2OH. This is how we can draw the structure of this triose ketose sugar. Another example of tetrose sugar. Tetrose sugar means the sugar that contains 4 carbons. This one, 1, 2, 3 and 4. 4 carbon. So like this structure, we can draw this structure. It is aldose sugar, so show this CHO group here and COOH group at the bottom. Rest of the carbons, HOH, HOH. Likewise, a ketose sugar having 4 carbons, 1, 2, 3, 4. This carbon, CH2OH, the last carbon, CH2OH. Here, this carbon is having keto group, that is C double bond O, just like here. In addition to that, there is one more carbon that will be surrounded by hydrogen atom and hydroxyl group. This will be the structure. This is the structure of erythrose sugar, and this will be called as erythrulose sugar. Then the next example, sugar containing 5 carbons are called as pentose sugar. So the example of pentose sugar that belongs to aldose category, that is which contains aldehyde group, is ribose sugar. And in case of ketose category containing 5 carbon, it will be called as ribulose sugar. Now let us see the structure of ribose. So likewise, while drawing it, as it is 5 carbon, draw 5 carbons, 1, 2, 3, 4 and 5. Then make this group as CH2OH, this group as CHO, and all the rest of the carbons will be surrounded by HOH, HOH, HOH. This is the structure, planar structure of ribose. This is the structure of ribulose. Again, you have to draw 5 carbons. This group make it CH2OH, and the first one CH2OH. Second one ketone, that is CO. Third one HOH. Fourth one HOH. This is the structure of ribulose sugar, which is a keto sugar containing 5 carbons. Next is hexose sugar. So as it is mentioned, hexose is 6 carbon containing sugar. So this example, this is the sugar containing 6 carbons. So draw 6 carbons, 1, 2, 3, 4, 5, and at the bottom 6. The first group, make it CHO, and the last one CH2OH. Rest of the groups you have to mention hydrogen atom and hydroxyl atom. Now here what we see is that carbon number 1, carbon number 2. So around carbon number 2, the configuration of HOH minus ions are HOH. The configuration around carbon number 3 is OH. Carbon number 4 is HOH. Carbon number 5 HOH. So what you can see here is that at carbon number 3, the configuration of HOH ions are OH. This you need to remember this position while drawing the structure of this hexose sugar. This is the structure of glucose. 1, 2, 3, 4, 5, 6 carbons, and at carbon number 3 the position should be OH. This is the structure of glucose, the planar structure of glucose. Then hexose sugar having ketone group. So while drawing it again, make sure that you have drawn 6 carbons, 2, 3, 4, 5 and 6. The first carbon CH2OH and the last carbon CH2OH. Carbon number 2 C double bond O. Now see the position of HOH group. It is OH, similar to this glucose, OH at carbon number 3. Here also OH at carbon number 3, and rest of the groups are HOH. This is the structure of fructose. So this is glucose and this is fructose. One more example is this sugar. Again it contains 6 carbons. This is an example of hexose sugar. 1, 2, 3, 4, 5, 6. Here what we can note that there is a terminal CHO group, carbon number 1, carbon number 2. At carbon number 3 it is OH, and again at carbon number 4 it is OH. This is the configuration around carbon number 3 and carbon number 4, that is OH. This is the structure of galactose sugar. This is glucose, which is aldose sugar. This is galactose, which is again aldose sugar, and this is fructose, which is a ketose sugar. As mentioned earlier, that whenever present in aqueous solution in cytoplasm, ribose, the pentose sugar, which is a type of aldose sugar, it is present in ring form. So we can see here, this is the ring form of ribose sugar. This is carbon number 1, 2, 3, 4, and this is 5. This is structure of glucose, which is present in ring form. Again, we need to remember this structure. This is carbon number 1, 2, 3. Now you see position of OH at carbon number 3 is OH. Carbon number 4 HOH, and carbon number 5, carbon number 6 CH2OH. So this is the structure of glucose. In order to understand whether the structure is correct or not, you need to check the number of atoms. So glucose is C6H12O6. Let us see whether there are 6 carbons or not. 1, 2, 3, 4, 5, and this is 6. H12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2, 12. Then O6, 1, 2, 3, 4, 5, 6. C6H12O6. Likewise, you can check whether the structure of ribose is correct or not. Carbon number 1, 2, 3, 4, and 5. Oxygen 1, 2, 3, 4, and 5. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the structure of fructose present in ring form. 1, 2, 3, 4, 5, 6. So the formula for fructose is also C6H12O6. We can note the difference between glucose and fructose. This is aldose sugar and this is ketose sugar. The molecular formula are same, C6H12O6, C6H12O6. The difference is only in the arrangement of this carbon atoms. So this is carbon number 1, 2. At carbon number 3, the orientation is OH, H, 4, 5, 6. This is the structure of galactose. As we have seen earlier, galactose has orientation of OH around carbon number 3 and 4. This is carbon number 1, 2. This is carbon number 3. The orientation is OH, and carbon number 4, OH. Rest of the things are same as the things are in glucose. The molecular formula is also same for galactose, C6H12O6, 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 C5H10O5. Likewise, these are the examples of pentose. Ribose is a principal component of nucleotide. It is present in DNA and RNA in the form of deoxy and deoxyribose sugar and ribose sugar respectively. These are the energy-rich compounds: glucose, galactose, and fructose.